In this video, we are going to discuss matrices, SAQs, exercise 3D, section 2, third problem. Show that determinant of y plus z, x, x, y, z plus x, y, z, z, x plus y is equal to 4xyz. Now, here, given that determinant of y plus z, x, x, y, z plus x, y, z, z, x plus y. See here, the given determinant is, we have y plus z, x, x, y, z plus x, y, z, z, x plus y. See how to prove this. What I am doing is here, applying the row operations. First what I am doing is R12, R1 minus R2. Here what is R1, R2, R3? This is R1, here this is R2 and this is R3. See here, what I am doing is first R12, R1 minus R2. See y plus z and R2 is minus y and here x plus z plus x is there, so x minus of z plus x, R1 minus R2 and here x minus y. Then again what I am doing is, if you observe here y is there, here z is there, here z plus x, z, y, x plus y. To eliminate this z and this y, now I am operating the operation R2 to R2 minus R3. See what we get. So y minus z, writing in the place of R2, z minus z plus x minus z plus x minus z, and here y minus of x plus y. See R2 to R2 minus R3, writing in the place of R2 and doing that R2 minus, subtracting R3 from R2. Did you understand? Now here z and z, so x plus y. I hope everybody understood. Now here, if you observe that, here plus y minus y gets cancelled, and here also z plus z minus z gets cancelled, and here further if you simplify this is, so which is equal to we get, so this is z here and here x minus z and minus x, if you multiply with minus, here x minus y, here y minus z, and here again we get x and here y minus x minus y, if you multiply with minus, and here z, so here z and here x plus y, and here x plus y. Now what happens here? Plus x minus x gets cancelled, and again here, so in the second row, plus y minus y is also gets. So what is left over here, which is equal to determinant of, we have z and here minus z and here x minus y, and here y minus z, here x, and here minus x, and here z, and here again z, and here x plus y. See, to reduce the elements, again what I am doing is here, so here z is there, here minus z is there, and here z and plus z is there. To eliminate one of the elements, that means to becomes one of the elements of either R1 or R3 as zeros, here plus z is there, minus z is there. So that's why what I am doing is, here C12, C1 plus C2 I am operating. So C1 is this, and C2 is this, C3 is this. So now if you add C1 and C2, so z plus minus z, and here y minus z plus x, and here Z plus Z, and C2 is as it is minus Z x Z. So x minus y, C3 is also as it is, there is no change in the C3 also. See why I added C1 and C2 here, writing in the place of C1. So here when you add C1 and C2, this plus Z and minus Z gets cancelled. You get one of the elements in the first row as 0, and here this minus Z you can write as it is, and x minus y we can write as it is, and here so x plus y minus z you can write in order. So here x and here minus x, and here z plus z is 2z, z plus z is 2z, and here z, and here x plus y. See, now we have this in matrix. So from this you can find the determinant. You can expand the determinant easily. One of the elements is 0 only, no? So that's why easily we can find the determinant. We can expand the. This is expanding using the first column. This is 0 into determinant of a. So 0 present in column and row, if you delete x minus x. So z x plus y, and here if you take along the first column, no, that is minus of x plus y minus z into determinant of a. So this is the first column, and second row if you delete. So this is we get minus z x minus y and z. So x plus y determinant of, and here last element with plus 2z into determinant of a. So this is minus z x minus y, and here x minus x. So like this we get last element if you last row and first column if you delete. So here this is 0, and this is minus of x plus y minus z. So into here if you multiply these two, so we get minus zx minus yz, and here so immediately minus z into x minus y. This is minus z into x minus y. Again plus 2z into here. This is zx, and here minus x into x minus y. Like this we have to multiply. We get which is minus of x plus y minus z into this is minus zx minus yz minus zx, and minus into minus is plus yz, and plus here if you multiply this is 2z into, so this is zx minus x square, and minus into minus is plus xy. So now here plus yz minus yz gets cancelled. Here this is minus of x plus y minus z. So into here minus 2zx, and here if you multiply with a plus 2z, so plus 2z square x, and here minus 2zx square, and here plus 2xyz we get if you multiply the three terms with 2z. Now here this minus into this minus is plus. Now x plus y minus z, so into, so this is 2zx, and here plus, so 2z square x, and minus 2zx square, and plus 2xyz, writing as it is. Now every term if you multiply with so 2zx, now we get 2zx square plus 2xyz xyz, and minus 2z square x plus 2z square x, and minus 2zx square, and plus 2xyz. See, if you observe carefully here, plus 2zx square, so plus 2zx square and minus 2zx square, these two, and plus 2z square x minus 2z square x, plus 2zx square and minus 2zx square, plus 2z square x minus 2z square x gets cancelled. So we have here left over only 2xyz. So which is 4xyz, which is only the RHS we require to prove. So therefore LHS is equal to RHS. So like this we can prove this problem.